Hey F Block, sorry I can't be here today, but we're gonna keep going with the lessons. But before we do anything, just want to let you know about the quiz for this coming Monday. So for Monday, what do we got? You should be able to prove identities like we've done so far. You should be able to simplify expressions, so any of those trig expressions that we've done using your identities. You should be able to write one expression in terms of another. So if that's right tangent just in terms of sine, or secant just in terms of sine, or something like that. And then the quiz will involve using the sum and difference trig identities. And so you need to have those memorized. The sine alpha plus beta identity, alpha minus beta, cosine alpha plus beta, cosine alpha minus beta, and to be able to do problems similar to the homework and what we did in the lesson. So if you do have any issues with those, just come find me either today after school or Friday before school or at lunch, and I can help you out with those. Okay, so that's what's on the quiz. As far as today goes, we'll be moving ahead. So we found sum and difference identities. Now what we want is we want to find identities for double angles. So how do you find sine of 2 theta or cosine of 2 theta? And we're also going to want half angle identities. How can you find half angles? So that'll be a good next step for us. Open some more doors for what we can do. So we'll start first with the double angle for sine 2 theta. So we want to figure out an expression for sine of 2 theta. So you might already see the direction to go. You can always write 2 theta as just sine of theta plus theta. And since you know your sine sum identity, you know that is just sine theta, cosine theta, plus cosine theta, sine theta. Notice that both terms have one sine and one cosine, so they're the same thing. So all of that just equals, sine 2 theta just equals 2 sine theta cosine theta. There's identity. QED. So I want you to do one. So your turn. That says your turn. Oops. Find an identity for cosine of 2 theta. You can pause the video and see if you can figure that out. Okay, so now I'll show the solution. So cosine 2 theta you can write as cosine of theta plus theta. So that'll be cosine theta minus sine theta, where you can say that cosine of 2 theta equals cosine squared theta minus sine squared theta. QED. But maybe you want to have it just in terms of sine, or maybe you want it just in terms of cosine. So you could start with the cosine squared minus sine squared, and you could substitute. If you wanted to have it in terms of sine, you could say cosine 2 theta is equal to, instead of cosine squared, write 1 minus sine squared theta minus sine squared theta. So that is, we're putting in place of the cosine squared, we're putting 1 minus sine squared. So that just leaves us with cosine 2 theta equals 1 minus 2 sine squared theta. Okay, so that's a equivalent expression. Or you could do it all in terms of cosine. So you could say cosine 2 theta equals, so we've got the original cosine squared minus sine squared. So we'll substitute 1 minus cosine squared in place of sine squared. Like that. And so that simplifies out to just 2 cosine squared theta minus 1. When you distribute that negative. So you have 3 equivalent expressions for cosine of double angles. So one example of how you can put this to use is the following. If sine alpha is 4/5 and alpha is in the second quadrant, then find the following. First, just sine of 2 alpha. Sine of 2 alpha. Now, you know that based on our formula for sine 2 theta, you're going to need 2 sine theta cosine theta. That means we're going to need cosine alpha for this problem. So let's figure out how we can get cosine alpha. We know alpha's in Q2 and sine is 4/5. Well, you can show that this value would be -3, and therefore cosine alpha would be minus 3/5. Okay, so now, back to the problem. Using our identity, sine 2 alpha is just 2 sine alpha cosine alpha, which is just 2 times 4/5 times -3/5. And that'll give you a final answer of -24/25. Okay. So now you try this one. Try and find cosine of 2 alpha. You can pause the video and solve it yourself. Here's the solution. Well, that's just cosine squared alpha minus sine squared alpha. Substitute what we know. Minus 3/5 squared minus 4/5 squared, or 9/25 minus 16/25, which is just -7/25. Okay. So now what we're going to do is we're going to prove the half angle identities. So we want sine of theta over 2 and cosine of theta over 2. Well, we're going to use our cosine double angle identity. So we know that cosine of 2 theta is equal to 1 minus 2 sine squared of theta. So this is pretty clever. We're just going to rewrite that, but instead of cosine 2 theta, we write cosine of theta equals 1 minus 2 sine squared of theta over 2. So as you can see, we just replaced all of the thetas with theta over 2. because 2 times theta over 2 will be theta. And then for the minus 2 sine squared theta, that just becomes minus 2 sine squared of theta over 2. Okay, but we want the identity for sine theta over 2, so we got to solve for it. So we can move the 2 sine squared theta over 2 over to the left side, and move the cosine to the right side. Just start solving for theta over 2. Take the square root. And you are left with this as your identity. Okay. So that's the sine half angle. That's exciting. So now you try this one. You try and get the cosine theta over 2. So you'll start by using this identity. Alright, give that a shot. Okay, so you would substitute theta over 2 for theta and get this equation. Do like we did with cosine with sine on the left, so we're trying to get cosine theta over 2 by itself. So we'll have 2 cosine squared theta over 2 equals 1 plus cosine theta. Divide by 2 and square root. Okay, so divide by 2 square root plus or minus. Alright, we got our 2 half angle identities. And notice that these are the same except they differ by a sign. So sine of theta over 2 has a 1 minus cosine theta. Cosine theta over 2 has a 1 plus cosine theta in the radical. So we'll do an example. So for these, find the exact values of the following. Sine of 5 pi over 8. Oops. Sine of 5 pi over 8. Well, you can actually say that that's a half angle. So that's sine of 1/2 of 5 pi over 4. And that lets us use our identity. So it's going to be the square root of 1 minus cosine 5 pi over 4 over 2. And you got to decide, is sine of 5 pi over 8, is that a positive or a negative thing? And so you think about where it is in the unit circle. 5 pi over 8 is going to be in your second quadrant. And so for sine, which is a y value, it's going to be positive. So you'll take the positive square root when you're getting your answer. Anyway, this becomes 1 minus root 2 over 2 over 2. Okay, and so then you'll need to get a common denominator between 1 and minus root 2 over 2. That gives you, 2 over 2 plus root 2 over 2, so 2 plus root 2 over 2. All of that over 2. And then you can treat the bottom as a fraction of its own and multiply by the reciprocal. In any case, you get all of this is 2 plus root 2 over 4. Or in other words, since the 4 you can take the square root of on the bottom, you can leave it as 2 square root of 2 plus root 2 over 2. The square root of 4 is 2. Don't be intimidated by the way that answer looks. It's okay to have square roots within square roots. So then, why don't you try this example? Find the cosine of 5 pi over 8. You try that. Okay, so 5 pi over 8 is still in that second quadrant, which means cosine is negative. So we'll say cosine 5 pi over 8 is cosine of 1/2 5 pi over 4. So this will be negative square root of 1 plus cosine 5 pi over 4 over 2. Okay, 1 plus negative root 2 over 2 over 2. Negative 2 minus root 2 over 2 over 2. Minus 2 minus root 2 over 4. Or a final answer of this minus root 2 minus root 2 over 2. Okay. Now we're going to look at an example of doing a proof using these identities. So let's see. Prove this identity, that sine of 2 alpha divided by 1 minus cosine of 2 alpha is equal to cotangent alpha. So hopefully you can tell that the left side is more complicated. Probably a good idea to start with that one. I'm just going to start rewriting it in terms of my double angle identities. So sine of 2 alpha becomes 2 sine alpha cosine alpha. And on the bottom I'm going to replace cosine of 2 alpha with cosine squared alpha minus sine squared alpha. Okay. What does that leave me with? 2 sine alpha cosine alpha over 1 minus cosine squared alpha plus sine squared alpha. Now you should see that this 1 minus cosine squared can be turned into just a sine squared. So all that will just be 2 sine alpha cosine alpha over sine squared alpha plus sine squared alpha. So that is 2 sine alpha cosine alpha over 2 sine squared alpha. You get your 2's to cancel, one of your sine on top, one on the bottom, cosine alpha over sine alpha, or just cotangent alpha. That's what we're trying to prove in the first place. So rejoice. Okay. Another example. If, oh, 1 second. Oh no. Okay, my mistake. I thought I stopped recording. It's about to panic, 20 minutes gone. Okay, so let's see. Example 4. If 180 degrees is less than Alpha is less than 360 degrees, so that's where alpha is. And cosine alpha is negative 12/13. Find sine alpha over 2 and cosine alpha over 2. Well, since alpha is between 180 and 360, then if you divide all those things by 2, you get that 90 is less than alpha over 2, less than 180. So that means alpha over 2 is somewhere here in the second quadrant. Does that make sense why cosine is this negative number, negative 12/13? You can check, but you should find, well actually I was going to say you could find sine of alpha over 2, but you don't need it in this case. But if you did want to, I think you could find that it's 5/13. Anyway, to find sine alpha over 2, well, you know it's going to be positive. Oh, excuse me, 1 second. I realized I drew this triangle wrong. I labeled it as though this were cosine alpha, negative 12/13, but this is the angle alpha over 2, so it would probably have different values. The important thing to get from this is that sine alpha over 2 is positive and cosine alpha over 2 is negative, based on where that angle is located. So anyway, sine alpha 2 is positive, so it's the positive square root of 1 minus cosine alpha over 2. 1 minus 12/13, because cosine alpha was given. Get a common denominator. 1 becomes 13/13. Minus, so 13 plus 12 would be 25/13 over 2 over 1. You'll see this becomes 25/26. And you can simplify that down to 5√26/26. I'll give you a second, pause the video, see if you can do B. Okay. Cosine alpha over 2. We said that cosine alpha over 2 was negative based on where we drew alpha over 2. So then we know it's negative root 1 plus cosine alpha over 2. That's negative 1 minus 12/13, plus minus 12/13 over 2. It gives you minus root 1/13 over 2, or minus root 1/26, which can be put in simplest radical form as minus root 26/26. Okay, so that's all I have for you right now. Here is your homework assignment that goes with this. That'll be page 649, numbers 1, 5, 9, 13, 17, 21, 25, 27, 33, 35. If you have other questions, you can definitely come see me later. But also make use of the worked examples in your textbook. Those might help you a lot as well. But that's all I have for you for now. If you have more questions, come see me, but I hope this was helpful. and I will see you guys later. Don't forget about your quiz on Monday. It will not include this new stuff about double angles and half angles, just the stuff I mentioned at the beginning of the video. Alright,